There are a couple things I'd like to go over when we talk about turning whole numbers or integers into fractions. So the first thing is you can always turn an integer into a fraction by putting it over 1. So -3 equals -3 over 1. You can do that with anything. So 8 would equal 8 over 1. 0 is 0 over 1. Okay, so you can always put something over 1 to make it into a fraction. Another thing I like to show you is that when we come to negative fractions, it doesn't matter where in the fraction there is the negative sign. So if the negative is in the numerator, that's just as well as if the negative was in the denominator, and that's just equal to if the negative was right outside the fraction sign. So all of these different expressions mean the exact same thing. The negative can be on top, on bottom, or right in the middle, okay? Now, I do want to caution that if you have a negative fraction, there can only be one negative sign. You can't have negative signs appearing in different places. If there were a negative sign in the numerator as well as a negative sign in the denominator, well, these two negative signs would cancel each other out. When you have two negatives, they cancel out to make a positive. So if you have a negative and a negative, that cancels out to be a positive over a positive. So that would be a +3. So two negatives equal a positive. If there is a positive, you don't need to put the actual sign positive. It's just implied that it's positive. So I also want to go back to having 0 as a fraction. So 0 can be written as 0 over 1. In fact, 0 could have been written over anything. And this is only true for 0. So 0 could have been over 2 or over 100. All of these equal each other, whereas if I want to write 3 as a fraction, it needs to be over 1, okay? So I couldn't write, it would not equal 3 over 4. It would only equal 3 over 1. Now that doesn't mean I can't write other fractions that also equal 3. For instance, if I had 6 in the numerator, then I would need to have 2 in the denominator. Do you see how 3 over 1 equals 6 over 2? 6 over 2 is 3. 2 goes into 6 3 times. 1 goes into 3 3 times. So just as we had doubled the top and doubled the bottom, and we could double it again if you want. You could say 12 over 4. That also equals 3. Whatever you do to the numerator, you have to do to the denominator in order to keep the fraction equivalent, okay? So nothing is different when we're working with 0. So when we have 0, we can all put it over 1, great. And remember, I can do whatever to the top as long as I do it to the bottom. Numerator is treated equally as the denominator. So if I were to multiply the top by 2, 2 times 0 is 0, the bottom by 2, 1 times 2 is 2. Or I can multiply the top by 100 and the bottom by 100, or the top by 50 or the bottom by 50. Here I'm multiplying the top by 50 and the bottom by 50. 50 times 0 is 0, 2 times 50 is 100. I could do it 1,000 times 0 is 0. 1,000 times 2 is 2,000. That's why all of these equal 0, and all of these down here equal 3. Even though